What's up, all you badass mathematicians? So today we're going to continue on with limits, and we're going to take a look at this function. So this is a piecewise function that's defined by x squared plus 3 when x is greater than or equal to 3. And it's defined by ax minus 7 when x is less than 3. So x is our variable, our input here, and a is just some constant that we're going to be trying to figure out. So our goal today, we're trying to find a value of a such that the limit of x, the limit as x approaches 3 of f of x exists. So to further illustrate our goal in this session, let's look at an example of when a is equal to 1 and what this graph of this function looks like. Example, a is equal to 1. So wait, actually, I learned something new the other day. Straight line tool. Very clutch. Now I don't have to freehand all these graphs. Alright. Kind of slanted. Okay, we're going to redraw that. There we go. Alright. So x squared plus 3 when x is greater than or equal to 3. So at 3, we're going to have 9 plus 3, let's say this is 12. And then plugging in 4, we have 16 plus 3 is 17. So maybe it looks like something like this. And if we're saying that a is equal to 1, then that means when x is less than 3, our function is defined by x minus 7. So let's say this is minus 7, and we have a slope equal to 1. So let's say, well, let's see what the value would be at 3 if this was defined at 3. So 3 minus 7 is negative 4. So we would be somewhere like right here, except we know that it's not a function if we have two values for the same x values, and since 3 is defined in our first interval, we got to be careful. And make sure we represent this with an open circle to indicate that our value is actually up here and not down here. Alright, so now let's connect these. I'm going to pretend that that's good. Alright, so the idea that we're illustrating here is right now when a is equal to 1, there's this large gap, which means that our function cannot be, the limit cannot exist. Because if we take our right hand limit, so the limit as x approaches 3 from the right of f of x, so this is when a is equal to 1, is going to be the limit as x approaches 3 from the right of x squared plus 3, which is equal to 9 plus 3, which is equal to 12. So then if we were to then find the limit as x approaches 3 from the left of f of x, we would now be looking at this segment of our piecewise function. So this would end up being the limit as x approaches 3 from the left of we're saying a is equal to 1, so x minus 7. And this is going to be equal to 3 minus 7 is negative 4. So right now our right hand and left hand limit do not agree, which means by definition our limit does not exist. So our goal here is we want to find a value of a such that we don't have a disagreement in our right hand and left hand limits. So essentially when we're doing this problem, let me do this in a separate color. Okay, green. So our goal is we're trying to find a such that the limit as x approaches 3 from the right of f of x is equal to the limit as x approaches the limit as x approaches 3 from the right of f of x is equal to the limit as x approaches 3 from the left of f of x. In other words, we want to make sure that the limit as x approaches 3 from the right of x squared plus 3. Again, because we're talking about approaching from the right, we're going to be looking at the right hand part of our piecewise function, because this is where x is greater than or equal to 3. And we want this to be equal to the limit as x approaches 3 from the left of ax minus 7. So what this will end up reducing down to is we're plugging in numbers really close to and approaching 3. And since we don't have a denominator in either of these numbers, we won't end up with a weird situation of 0 over 0 or some constant over 0. So this will then reduce down to 3 squared plus 3 is equal to 3a minus 7. So I'm plugging in for the limit here. And this will end up reducing down to 12 is equal to 3a minus 7 plus 7 on both sides, 19 is equal to 3a. So this means a is equal to 19 over 3. So if we want our limit to exist, well, then we should pick a equals 19 over 3, which means f of x will be equal to x squared plus 3 when x is greater than or equal to 3. And it will be equal to 19 over 3x minus 7 when x is less than 3. Alright, please leave any feedback or questions in the comments. I hope this was helpful, and I'll see you next time. Thank you.